Hello, and today's video is going to focus on molar mass. Okay, so the main goal for today is that you will be able to determine the molar mass from the atomic mass of an element. So you will be able to determine what the molar mass is of an individual element, as well you'll be able to determine what the molar mass is of a compound. That's the main focus by the end of this video. So what is molar mass? Well, the definition of molar mass is basically what is the mass of 1 mole, of a substance. The symbol for molar mass is big M. Okay, and the units that we use for molar mass is grams per mole. So yesterday we looked at, or the other day, we looked at Avogadro's number and the idea of the mole. Okay, and if we remember, 1 mole is equal to 6.02 times 10 to the 23 entities. Now that can be atoms, molecules. Okay, so it's entities. And what we're dealing with molar mass is we're trying to figure out how much does 6.02 times 10 to the 23 atoms or molecules of something weigh? And the reason why we do that is because then we're working with an amount that we can actually see. We can actually then observe how it reacts. And so if we're just working with one atom, that's very, very, very small. So we usually work with bigger numbers, so that's where the mole comes into play. So we're going to use carbon. So carbon, the atomic number is 6, and the atomic weight is 12.01 U's. Okay, that's the atomic mass. And in this case, U, the atomic mass unit, is very, 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 very small. If we remember back to Unit 1, it's actually defined as 1/12 the mass of a carbon-12 atom. So we're working with a very small number. So when we're dealing with molar mass, we're trying to figure out how much 1 mole will weigh. So how much is 1 mole of carbon? Well, conveniently, and it works out, there is a mathematical equation that we can use to work this out, and we will do that in class. But 1 mole of carbon actually weighs 12.01, but instead of atomic mass units, it weighs 12.01 grams per mole. So 1 mole of carbon weighs 12.01 grams, and this applies to all of the elements on the periodic table. So this is a oxygen molecule, so this is O2. Now what if we wanted to find the molar mass of a molecule like O2? Well, the molar mass, so big M for O2, is going to equal the mass of oxygen on the periodic table, but instead of atomic mass units, we're going to use grams per mole, because that's how much 1 mole of oxygen weighs. So we look at the atomic mass for oxygen on the periodic table, and we see that it's 16.00. And again, that's grams per mole. Now the only thing is that we have 2 atoms. We have the subscript 2. So that then has to be incorporated into your molar mass. So if there are 2 oxygen atoms in 1 molecule, the molar mass is going to be 2 times the molar mass of 1 atom. So then if you need to get your calculator out, you're going to multiply these 2 numbers, and we get 32.00 grams per mole. That's the molar mass of oxygen. We'll talk about significant digits in the next example. Okay, so this is an ionic compound. This is sodium sulfate. So it's showing you 2 atoms of sodium needing to react with the SO4 polyatomic ion. And then according to our crisscross rule, our formula would be Na SO4, sodium sulfate. So what if we have a larger compound like this? How would we find the molar mass? Well, we're going to look at the individual elements that make up the compound, look at the subscripts, and then use all that information to come up with the molar mass of sodium sulfate. Okay, so the molar mass of sodium sulfate, big M stands for molar mass. So what you're going to do is you're going to take the molar mass of sodium from your periodic table, but there's two of them, so you're going to have to multiply that molar mass, and then you're going to add it to the molar mass of sulfur, and then you're going to add that to the molar mass of oxygen. Now the only thing is that in this compound we have 4 oxygens, so you're going to have to multiply the molar mass of oxygen by 4. Okay, so I've written down some of the equation and I'll explain it. So we're dealing with the molar mass of sodium hydroxide. So the molar mass of sodium hydroxide, we're going to look at the molar mass of sodium times 2 plus the molar mass of sulfur times 2. So we have the molar mass of sodium here, and it has to be times 2. Now don't forget your units. Your units here are grams per mole. And then I'm adding it to 32.07 grams per mole. That's the molar mass of sulfur. And then, I can't forget my oxygen. I then have to add it to the molar mass of oxygen, which is 16.00 grams per mole. So now what I do is my bed mass rules. I'm going to multiply first, and then I'm going to add all of these molar masses together to give me the total. Okay, so 2 times 22.99 for sodium gives you 45.98 grams per mole, plus 32.07 grams per mole for sulfur, that doesn't change, plus 4 times 16.00 grams per mole for oxygen gives you 64.00 grams per mole. I'm now going to add that all up, and I get, okay, so the answer is 142.05 grams per mole. Now, how many significant digits are we going to have here? Now, these values, we were adding up numbers. Okay, I know there was some multiplication here, but we were adding them by a counted value. So, for instance, your 2 and your 4 are counted values. So we say there's an infinite number of significant digits there. So we look at the other numbers. Now, each one of them has 4, and each one of them has 2 numbers after the decimal place. Because we're adding up these numbers, these values, we have to make sure that our molar mass has 2 numbers after the decimal place.